smart greenhouse has four major components: the greenhouse controller, the cloud server and database, the desktop application platform, and the mobile application. We developed the greenhouse controller with a maximum of 50 inputs and 40 outputs and installed it inside the greenhouse. Each input can be connected to a different sensor and each output to a different actuator. The controller contains two units, a control unit implemented with Raspberry Pi 3 and an execution unit implemented with Arduino Mega. The controller can retrieve data and commands from the cloud server via the internet and update the cloud server with events that occur in the greenhouse. The cloud server is 24/7 software that holds all the data of the system, including data about registered users, the controller configuration, the experiment, and all events during the experiment period. The desktop application platform has several functions. It can add or modify a user on the system with specific permissions, for example, admin, teacher, student, and so on. The system works as follows. After a student user and a controller are defined in the system via the desktop application, the student can define a new experiment. For an experiment, the student defines the start and end dates, the experiment name, and the research question. The next step is to define the number of items, or flower pots, in the experiment. The student then defines the treatment groups, giving each group a unique name and quantity. Next, the student defines a specific execution scenario for each treatment group and defines the sampling rate of each sensor. Finally, the range of values for specific external variables such as plant height are defined. Once the new experiment has been defined, the desktop application platform uploads the experiment's data to the cloud server. When a student updates an external variable value via the mobile application, the relevant data is sent to the cloud server. When the experiment is up and running, the student can view graph reports for each flower pot or treatment group of flower pots that have been defined as treatment groups in the experiment. Our science students, with the guidance of science teaching staff, defined the following bio-research project. What is the effect of different ground cover on the growing rate of a chili pepper seedling? The students prepared 4 treatment groups of 9 flower pots, each with a different ground cover. The first group used sawdust, the second gravel, and the third group plastic pieces. A control group had no ground cover. Each flower pot contained one plant with a dedicated moisture soil sensor and a dedicated actuator water tap for watering that plant. And all the actuators and sensors were connected to the controller. All experiment data was updated by the students via the desktop application platform, and the experiment started. Students monitored their experiments and updated external variables values with the mobile application. The cloud server also sent each student a daily report for their experiment via email.